All right. Hello, everyone. Great to see you here today. Welcome to Solving Large-Scale Data Access Challenges with Amazon S3. My name is Rob Wilson. I'm a product manager on the S3 team. We've got Becky Weiss, who is a VP and Distinguished Engineer on AWS IAM, so Identity and Access Management. You have the right people here for this topic today, and we're going to explore a brand new feature called S3 Access Grants today. So we'll start off, we'll build a foundation here, we'll do a permissions overview. We'll talk about options for granting access to Amazon S3. So that'll include prefix-based access points. We'll talk about structured data and some different considerations there, building your own session broker to make dynamic access control decisions, and then introduce a new feature, S3 Access Grants, launched just earlier this week. So as Becky dives into that, that'll include a demo, that'll include a number of different topics. And then really the implied number 6 on this list, if you're curious, is Q&A afterwards. Encourage you to come up in the room afterwards, out in the hallway. I have nowhere to be in a hurry after this session, so I'd love to answer questions, try to talk to you as many as possible after the session. As we kick off with that permissions overview, we're going to start at a very high level and continue to work our way down and get into more of the details as we roll on today. Security is not a new concept. Putting valuable things in secure locations has been around for a long time. So we're going to build on that foundation and think about, OK, I want to secure something, but who do I want to grant access to? I want to have a means of access control. I need to let some people in, but I want to make sure the right people have the right access to the right data. And as we start to talk about data, let's not look at that fortress on the right. Let's actually look at buckets. And in this case, lovable mascot S3 buckets. I've got the T-shirt on today. They let me wear it. Thanks, Val. I see you in the back. So for the purpose of the rest of the presentation, we'll use the simplified bucket diagram. It proved to be a lot easier to fit into the layouts. And we've got our users. We want to grant access. And a lot of times, it's not just the whole bucket that you're granting access to. A lot of times, you and other customers are storing data in the bucket in different prefixes. You're laying out the data in a way where you can grant access to certain teams, certain users to those different prefixes. We'll go plenty into detail on that. As we talk about buckets and granting access, I want to remind you all that buckets are secure by default. You are the only one who has access to your bucket when you create it. You can then grant access to others. So it's building up that access for others, but you start with it just secure by default. 2 best practices we recommend to customers are turning on block public access. For nearly all your buckets, you've got account level and bucket level controls. So block public access is another feature to look at as you're controlling access to S3 buckets. And the other one, disabling access control lists. Talked to a gentleman in the audience earlier talking about access control. Hey, I want to make sure people are granting access through the right means. You've got policies, you've got user policies, resource policies to grant access. For a lot of customers, turning off access control lists makes a lot of sense. And that's why we have that control to disable ACLs. I mentioned these are both best practices, and in April of this year, we actually rolled out those best practices automatically for all new buckets. So any new bucket created starting in April of this year has block public access enabled and has ACLs disabled by default, so it just picks that up. You can change those options. Most customers are leaving them exactly the same. Makes sense for most use cases. All right. Next, we're going to look at the roadmap for this session and really look at all those options for access control. And as your scale and need for granularity grows, that's where we're going to build up to that new launch of S3 Access Grants. So we'll start with IAM basics. We'll look at some examples. We'll look at statements on how you can build policies to grant access. Then we'll talk about prefixes, both granting access to particular users to access a prefix, but also building a bucket policy that grants access to individual prefixes. We'll then move up to access points. You'll see how that allows you to scale your policies in a very large scale. So 10,000 access points even just to start with. That's just the soft limit. So you have a lot of policy space there on access points. We'll then take a right turn. And I wish I had a laser pointer, but they didn't give me one. We'll take a right turn over to lake formation and talk about structured data. Very different needs for access control there. Then we'll talk about an IAM session broker pattern. So this is if you want to make dynamic access control decisions for individual users. And at that point, you'll have a lot of foundation on different means of access control. And then we'll talk about S3 Access Grants. Becky will come on stage, talk you through the feature, and do a deep dive. And you'll see how all of these are connected, and it really builds on IAM principles you're already familiar with today. All right? And I couldn't miss putting that little badge on there. It's new, just 3 days old at this point. It is GA. You can use it right now, but I encourage you to wait until after the presentation to get those laptops out. So we'll dive in. All right, starting with IAM basics. This will feel like basics for most of you, but I love to go over them. We have a get object request coming in from an IAM principal to our example bucket. Is that get object going to be successful? Is access granted? We're looking at both our IAM principal policy, so the policy that's on the user side, and also looking at the bucket policy to see if access is granted. Here, as we look more into detail on the policy, you see there's an allow for get object and put object, and this one's very specific. It's for specifically the submarine object in the yellow prefix. So you can be as specific as an individual object as you write policies, and more likely for a lot of customers, you're going to write that policy to be for a particular prefix. So then you can say, hey, I'm storing this team's data. They're storing it all in a particular part of the S3 bucket. I'm going to write a policy that's going to scale over time to all the data that's put into that prefix. So you see how this is flexible. You can build on it, and you've got all those controls to apply to different actions. Here, we're looking at a cross-account scenario. So for cross-account, you've got a principal coming from another account altogether. So they've got to allow themselves to read into your account. Hey, do I want my users to read into another account? That's got to be explicit in that policy. And then looking at the resource here, does the bucket allow access from that other account into the bucket? So you've got these two policies that are both evaluated. They both have to agree to grant the access. In a single account, single authorization, and looking at it, if it's in the user policy, if it's in the resource policy, it really just needs one of those to be granted, no denies, and that'll work within a single account. Let's keep building up the story. Let's talk about those prefixes I hinted at earlier. And for the first scenario there, we were looking at one statement. But here, we're going to start looking at, what if I have a lot of users accessing a number of different prefixes in the bucket? So here, once again, we're looking at our allow statement. We've got a get and a put, and now we're on the blue prefix. So same wildcard that we saw earlier to access that blue prefix in the bucket. Get object request comes in, accessing an object in the blue prefix. You can see how these things fit together on a request level, and then the statement applies to that blue prefix. So here's where we start to get into a little bit of math to say when certain means of access control are going to be the best fit for you. This is about 251 characters. I'll give Becky all the credit for running the math here. But we've got our allow statement here for get object. OK, about 251 characters. That takes up space. And the reason we're talking about how much space it takes up is that your bucket policy does have a limit of 20 kilobytes. So we've got an allow statement for get object. Now we're looking at a pretty likely scenario where you might also grant allow for list. So I've got allow for get, allow for list, and now we're up to 550 characters. So one of the things to think about when you're granting access is how many users, how much granularity do you need? And here, when we added that different policy statements for the read, for the list, and we've got a max bucket policy size, we were looking at the numbers ourselves, and things like object key length matter here and the length of the prefixes, et cetera. But using some rough numbers, I can grant access to about 30 prefixes if I'm doing the list and get scenario that we just looked at. You can do about double that if you don't have the list permissions as well. But you see how the scaling here is based on number of prefixes drives the policy size. And we're looking at about 30 or 60 here. We have plenty of customers where there's many more teams, many more individuals accessing different parts of a bucket, so you might need other means of access control. Fortunately, I have one that's very similar to this. And that's putting the policy on the user side, on the IAM user policy, rather than on the resource side. So let's look at how that would work. We could have people who use a red role, a yellow role, and a blue role to access this particular bucket. So here's an example. We're just putting a very similar policy to what we saw earlier. We're using that allow get object to the blue prefix and applying it to the blue user. Where this one scales well is you can do many of those different policies, and we're not having to write it all in the bucket policy. Note in the top right of this slide, I think from your perspective, same account use case, but we can talk about the subtleties here. When I introduce that orange role, where they've got to read from multiple prefixes, this is where the scaling comes in on this particular model. I can't just say orange is the combination of yellow and red. I have to build a new role that is the orange role that is very explicit on what it can access in the bucket. So if you have many different prefixes and many different combinations, you're going to find yourself creating a lot of different IAM roles to match that. And you have a fairly high limit. You have 1,000 IAM roles per account, 5,000 max. So you can grow that number fairly high. but the combinations of a lot of different prefixes within an S3 bucket can add up quickly. So that unique use cases drives the number of IAM users you have to do. This is going to work really well for strictly role-based access control, where you can use that IAM role. They can log into AWS. They can assume the role. And the part I talked about earlier on the bucket policy side, in the same account, it's going to work just as we saw before. But if it is cross-account, you're going to want a fairly small number of cross-account use cases, because you're also going to need the corresponding bucket policy as well. So something to consider on how this would scale up. Continuing to build up on this roadmap slide. So talking about access points next. And each time, we're going to add a little more flexibility to your means of access control. We're back again. We've got red, yellow, blue. We saw this case earlier. But what if I add way more colors and way more prefixes? So looking at this, you now have that case we were describing earlier, where there may be many, many more prefixes. And when you've got many more prefixes, we talked about the bucket policy may hit a scaling limit. We may not want to create all the IAM roles and have those different combinations. So what if we use a different method? What if we use access points? And for those unfamiliar with access points, giving you a quick recap, we've got those requests coming into S3. And instead of going directly to the bucket, they go to an access point. The access point is tied to the bucket. It's created, associated with a particular bucket. But the requests go through the access point. That allows me to write a policy on the access point to make a judgment on what requests come through and what requests succeed to S3. So you see here, looking at that diagram, you've got that access point policy that's unique to each access point. Those are all 20 kilobyte policies. You can put a lot of granular statements into that access point policy. And then it's specific for the red users, the blue users, the orange users coming into this bucket. And a nice benefit of this, and as we talk through this with customers, is I've got those granular, fine-grained controls on the access point policy. And then on the bucket, I can do coarse-grained controls that I want to apply to everything. One of my favorite examples from a data protection standpoint, we can talk about it later, but for users that want to use versioning on a bucket, use lifecycle to clean everything up, and make sure no one does a version delete of a particular object in the bucket where they're deleting a specific version, you can just deny a delete object version in your bucket policy. Then it applies to all users, and then you're controlling things on a more granular level just on the access point policy. So you can do this for a large number of static access patterns. This is really for these members are part of a team. They access S3. If people are changing teams constantly, if you've got a lot of new access points you'd have to create all the time, maybe you have a more dynamic scenario. But here, up to 10,000 by default, 10,000 access points per account per region. It's a very high limit. And you have that separation of access points and buckets. So some considerations here. How do I find the right access point? I'm trying to read from an S3 bucket. Where's the list of access points? Where do I start? Where do I issue my request to S3? So that's something to think about. And we talked about if the patterns are a bit more dynamic, what are we going to do then? What are the other options? So now, before I shift to the next slide, we're going to take that right turn and talk about structured data sets right now. Really important to talk about as we get into the story on S3. So in S3, we looked at those examples earlier. We had things in red and yellow and blue, and it was a submarine, it was other things. Any kind of data can be stored in S3. That's one of the beauties of S3. And here we're going to look at Parquet files. Because Parquet files, it's not just an object. It's probably rows and columns that you might want to control access to differently. So let's look at an example of that. Here we've got Alice, Bob, and Carol. They purchased something. We have price information for them. We have their location. So we have different information about transactions and what happened. So perhaps, as a company, I don't want everyone to have access to all this information about a customer or about a particular transaction. So I may have reasons to control who can read what part of an object. Now, that's an interesting one. That's not something we've gotten into yet. So here, as we look at example queries that you might run on this particular data stored in S3, our admin user can see everything. Makes sense. Admin user, they need to see all the fields. They need to do troubleshooting. They've got the control. But then we have some data user. I like this title. I like this name of this user. Some data user can only see the transaction number and the price. So I want to make sure the right users see the right information, and I have that fine-grained control. How do I do that? Well, let's dive in. So we've got our nice bucket diagram. We've got our CSVs. We've got our parquets, whatever files we have. And I've got this user. This is some data user, and I only want them to see the ID in the field. Let's see what IAM or S3 policy we can write to grant access to only parts of an object. And question marks. We just can't do it in S3 with the expressiveness we have. So we can't say you can only have part of that object. So we have tools in AWS, we have other services that you can use to then solve for this scenario. And it's a very common scenario for customers. We want to talk you through it as you think about those structured data sets. Some data user can only see price and ID. Very clear in here as we look at lake formation, you can see who can access what in this particular S3 location. So now we look at the scenario and see how it all comes together. Some data user wants to select everything where the price is less than 140. So we go to Lake. Athena is really the hub of all of this. So Athena is making the decision. Athena goes to lake formation. I'll go back one. Goes to lake formation to find out about some data user. What do we know about this particular user? Where is the data stored, and what data do I need to go fetch from S3? Let's go fetch that data. Now I have the data back from S3, and now Athena can make a decision. I know about the user. I know about the query they ran. I know how to filter the results, and then put it all together and return it to the end user. So you see here, Athena's at the center of everything, and using lake formation and glue, it's able to filter results to end users. Very common scenario for customers as they store more and more data on S3, low cost, long-term storage, and then the ability to query directly on S3 and get this kind of filtering back to an end user. Very, very powerful. All right. So now we're going to build that story towards S3 access grants. We've talked about prefixes. We've talked about access points. We've talked about user policies, talked about structured data. Now we're going to look at those dynamic access patterns. What if I have people changing teams? What if I have many, many teams in my organization? What if the controls I want in S3 are very, very granular and who can access what? That's where this pattern starts to come in. So this session broker pattern, we have customers that have built this out. We have customers we've worked with to help build this out. And this is something we've talked about for the last few years. So I want dynamic permissions at scale. I could build my own session broker. Emphasis here, this is all DIY. You could build this yourself. We'll get to the punchline later. So I have a data access request. A user comes in. Let's look at perhaps the red user. So they pass information to the session broker. They go and call and say, I want access to this S3 location. Here's what I want to read from S3. So I have a location. And I also have information about my identity and any other claims that get passed to the session broker. So now the session broker knows what they're trying to read and who they are. And now the session broker can make a decision. So this is really, you see the gear there. There's work happening here to look at who's coming in, what are they trying to access, can I grant this access or not. The outside, if authorized, we're going to then go to STS and get a short-term credential to hand back to this user. The great part about this, and you see it at the bottom here, is once you have that short-term credential, it is for a period of time. You can then use that to do many, many gets, puts, lists, head operations to S3. So I have a control plane, you can think about it, operation up here to get my credentials. And then I can go to the data plane and issue many, many requests to S3 without having to go back to that session broker. So it allows you to scale in a very unique way, and that's one of the things we'll highlight here. So first, we authenticate the caller. We make this access decision. Should they be able to access this data in S3? We call STS, kind of recapping what we did in the previous slide. And when I call STS, I now have this short-term credential, and I'll even follow along. It's going this way. I'll follow along. I'll return it to the end user, and then the end user will call that and use those credentials to call S3. So you see how it all connects together. And this is made dynamic in the moment. You can make these short-term credentials. These could refresh every few minutes. So then as people change teams, as something else changes in your organization, that decision is made in the moment before they're accessing S3. So this is a slide we're going to linger on for a second and really build it up in terms of why this pattern works well and why we did the work to build S3 access grants, make it so that you don't have to build this yourself. So the credential vending is built on AWS STS. So to get those short-term credentials, it's high volume. It's a regional data plane. It's a reliable system. It's something you can build on and really, take a dependency on and feel good about. Uses S3 for what it does best. S3 scales really well. And it scales to many, many requests and a lot of throughput. I don't want to go to the session broker every time I need to get an object from S3 because that's just too much of a bottleneck. So I want to get the credentials up here, and then when I go to S3, I just have these credentials I can use for a period of time, and then you can really issue as many requests to S3 as you need to get the data back. On that next one, it's very few resources you have to create. So we talked about IAM roles earlier. We talked about you may have many prefixes, many different combinations of access. You can create many roles, or you can use this type of model, and you create few roles, and then those roles are then used to scope down permissions to an individual user. So it's not a lot of IAM roles. Maybe it's one, maybe it's very few that you have to build to use this type of model. And then the last one, that part I was emphasizing earlier, the session broker really only has to scale on the number of credentials it hands out, not the amount of traffic to S3. There could be millions, billions of requests over a period of time, but I only need to scale based on the number of users and how many credentials I have to hand out. So that doesn't have to be high volume, that session broker component that you build out. So this sounds great. Sounds interesting. We all want to go build it right now. But what if you don't? What if you don't want to build this yourself? This is DIY. There's a lot of good fundamentals to it, but we had this conversation with customers. They like the model. They have complex access control scenarios, but they don't want to build it. They want to manage service, and that's what we're diving into next. So bring Becky on stage to talk about S3 access grants.
Thank you so much, Rob. All right, so we're thrilled to introduce this new capability of S3 access grants. But before I tell you what the solution is, maybe let's start with what the problem is. It's actually kind of three different categories of problem, three sort of themes of challenges that we saw our customers facing as their data lakes grew and as the access patterns became more complex and numerous and combinatorial. So the first category of challenge that, over many, many discussions over years, talking to customers about these growing data lakes with growing numbers of use cases, the first one actually maps pretty well to what we heard from Rob about writing these bucket policies. Sooner or later, if you're managing a data lake in S3, you have written a bucket policy that starts to look like this. Use case, permission for this use case, permission for this use case, permission for this use case. It gets longer and longer and longer. You can get up to 20K characters here. And if you think about what it takes to manage this, so I'll kind of abstract this away, statement 1, statement 2, statement 3. And let's say I have a new use case. It's time to add a new permission. Well, no problem. I just take this policy document. I slide in statement 3.5. And and then I can put the new bucket policy. This completely works. But you can sort of see it, particularly if there's a lot of different data sets in here and these policies are changing. You can see how this would, just for obvious reasons, this starts to create some management challenges, particularly like if you think of two different entities maybe clobbering each other. It's one monolithic policy document. So you have that issue if everything's partying on the same bucket policy. The second category of challenge is actually the big one. As we talk to customers with data lakes over the years, and particularly in the last few years, is more and more kind of analytical and machine learning, and now with the rapid growth of generative AI, the kinds of users who need access to your S3 data lake, well, they're users, they're people. And if you ask almost any company, almost any enterprise, well, how do you think about access to your data? They don't really start talking about AWS accounts and IAM roles. No, the way they'll talk about it naturally is they'll say, we have users and groups, and we have data sets, and we need to map them together, right? Kind of like this picture, right? And as Rob mentioned, here I have a separate data set orange, but a person could be in multiple of these groups. This is kind of a combinatorial problem. And how do I make that mapping? And at small to moderate scale in IAM, you can express this directly, but what if these users, what if they're not IAM principals? What if they're people who authenticated to an application, to a workbench of some kind to be able to do their work? Well, okay, so how would you do that today? Let's say you wanted to build a corporate application, an enterprise application, within your own company called the pie chart maker. The pie chart maker is going to reach back into your S3 data lake and make pie charts for its users. The kind of people using the pie chart maker, they're going to authenticate to your identity provider. That's how they use everything at work, and that's how they're expecting to use the pie chart maker. And what you'd like to do, you'd like the yellow user, when they're using the pie chart maker to be able to make pie charts about yellow things like lemons and sunshine, but when the blue user is using it, you want them to be able to make pie charts about blue things like blueberries and oceans, right? And how do you do that? Well, if you had to sit down before this week, you had to sit down to build that, we'd probably be talking about an architecture like this. You'd run the pie chart maker on some compute, either inside or outside AWS. In either case, you'd have the ability to get an IAM role, an identity in the IAM system associated with your compute environment. So if you're running an AWS compute environment, EC2, Lambda, ECS, EKS, et cetera, that just comes out of the box. You get an IAM role. And if you're running something on premises, you can use IAM roles anywhere. Your application has an identity in AWS. It's that IAM role. But if you're trying to implement that mapping of users to data, well, that role's not going to do it for you. The role actually needs permission to all of it. So you're going to need your application, perhaps even in business logic, to decide which users are going to see which pie charts. Because it's only your application so far that understands who these users are, and it's got to figure out what they're going to have access to. This is all well and good until the next week when we decide we need not just a pie chart maker, but also a bar graph maker. Okay, how do we build our bar graph maker? Well, we can do the same thing, right? We can give it an IAM role, maybe run it on EC2 or something, have it implement that mapping. Now, if you are an engineer, you already know the problem here. If you implement the same thing in 2 places, you got it wrong 3 times, right? You need mechanisms to make sure that these things are actually going to be in sync with each other. So this is a challenge, right? What you actually wanted to do is you wanted one thing implementing this mapping so that the right people got the right bar charts and they also got the pie charts, and regardless of how they got to the data, they have access to a consistent set of data. The third challenge, kind of related to that second challenge, the third category of challenge is one of audit. So if I build that pie chart maker today, and I turn on CloudTrail data events for S3. Certainly, every time the pie chart maker accesses an object in S3, there's going to be a data event for that. It's going to look a little bit like this, and it is going to tell me who accessed the data, and it's correct. The pie chart maker role made the request to S3. But I bet that's not actually what you wanted to know here, right? You wanted to know that, actually. You wanted to know that the pie chart maker was involved, but you wanted to know that this was the Magenta user using the pie chart maker, and nothing in this CloudTrail event is directly telling you this. Now, of course, this is possible to do. There's other CloudTrail events, and logs from your application. You can stitch this together. Many customers do. But it would be a lot more convenient if the Magenta user's identity had made it all the way to CloudTrail, wouldn't it? So those are our 3 common themes. These are the problems that we were working backwards from as we designed S3 access grants. Management, just, managing discrete grants is going to be easier than a policy. Expressing these kind of mapping in a way that's natural, that doesn't require pivoting through other things or implementing things in business logic. And finally, auditing who accessed what. So S3 access grants is our answer to these challenges. I'm just going to show you a screenshot of the S3 access grants console just so you can get an idea of what this is. Because actually, if you look at this, it sort of shows you what's going on here. What I have are access grants. And what they are specifically breaking this down for you. Each access grant is talking about a folder in S3. I'll say a little bit more about that word in a second. A prefix in S3. It's a simplified mode of access, either read access or write access. Read lets you read both contents and list objects. Write lets you write. And then the grantee, actually, you might be seeing something new here, which is the grantee. Sure, it can be an IAM principal. This is AWS. IAM is everywhere. But you can also grant directly to users and groups from your directory. If you remember challenge 2, expressing these mappings naturally, this lets you express it directly. Now I'm going to say just a word about folders. If you have a little bit of knowledge about S3, there's actually no folder in S3. S3 is object storage, where the objects have names. We call these object names keys. We allow the slash character. There's no folder. However, a lot of our customers, they look like folders. They look like directories. So a lot of our customers organize their data this way. Everything we're talking about here is really a prefix. It's really a substring match. So that's all it is. But most of you probably think about data in terms of folders, and S3 Access Grants is kind of designed to kind of match that way of thinking. So here, yeah, we do have folders. They're not actually folders. They're actually string matches. Now, before I continue, before I talk about how you use this or how you integrate it with it or what it means or when you should be thinking about using it, I know what some of you are thinking, because I would think exactly the same thing if I were you sitting in this presentation and I think about securing cloud resources. It's something I've been doing for a lot of years. You're like, hang on a second. Did she just say that there's a new way to grant access to data in my bucket? Is this a new thing that I need to worry about? Is this a bypass for IAM? No, it isn't. It's actually, and I'm going to give you a little bit of detail for the next couple of minutes. It's actually, you don't actually need to understand what I'm telling you in the next couple of minutes to be highly effective with S3 Access Grants, but I'm actually going to tell you exactly how it works. It works in concert with IAM. So IAM is still very much in play on every API request to S3. The physics of IAM still apply, cross-account physics still apply, your data perimeter in policy still applies. What this is this a layer on top of IAM, a gate on top of IAM that gives you the ability for more granularity and expressiveness than what you could get in IAM. So this is not an instead of IAM. This is in addition to IAM, making it more granular. And in fact, S3 Access Grants, you can and you almost certainly will have, if you're using S3 Access Grants for some of your use cases to get into the bucket, you are likely to also have direct IAM use cases. Like if you have something that's scanning your bucket, that's probably going to come in through IAM. These work side by side. They're not in conflict with each other at all. Okay, so why how does this exactly work? Why isn't this some kind of new access pattern? So you remember the session broker architecture. And the whole idea with the session broker architecture was, it was a gate in front of IAM. Your application wanted to enforce some kind of access pattern that you just couldn't do in IAM. Either you needed to express something that couldn't be said in IAM, you needed more dynamism, you needed more scale. So you built this thing that did everything you needed. Your applications, instead of going directly to S3 and with some sort of generic IAM role, first they went to this broker. They said, I need this access. The broker ran whatever business logic you built, made a decision, used the AWS Security Token Service, STS, to obtain a session off of a kind of a central IAM role, and then it. So there's your STS session, and then your application would go to town in the S3 bucket until the credentials expire. So remember, that was what happened, right? This doesn't create some alternative path to IAM. It's simply layered on top of IAM. It's doing IAM in a more dynamic way. And access grants is exactly the same shape as this pattern, except instead of the broker that you built, it's S3 Access Grants doing this same thing. So IAM still very much in play. This picture is why. Okay, so back to our 3 themes of challenge. I want to talk you through why we're excited that Access Grants is going to make these things a lot. If you have these challenges, why Access Grants is going to make things a lot easier for you. So the management actually probably should be fairly self-evident here, rather than if I needed to add a new use case to, needed to add a new use case to my bucket, a new use case came up, it needed some new permissions, I would just add another access grant. I wouldn't have to be like touching or risking making changes to the other one. Something can be cleanly removed here as well. So check. Manageability gets a lot easier just because we have these discrete grants that can be managed individually. Assigning access in a consistent way. So how does that get better? Well, We saw before our problem here was kind of two implementations of this picture, right? And so consistency was definitely something we were going to need to worry about. By using access grants instead, what we have is this map, this relationship is actually implemented in one place. You configured it in S3 access grants, and that's getting to be the deciding authority for both the pie chart maker and the bar graph maker. So S3 access grants is sitting on that table of grants that looks kind of like this, and it's going to directly express what each of these applications should be doing. So you plug in more and more applications, and it remains true that the Magenta user is going to have access to the Magenta data no matter how they got there. So check on consistent mapping of access. Finally, let's talk about audit. Remember, the problem that we saw before is there is a CloudTrail data event, and it does say who has access, but we wanted to actually know who, like which person had access. So S3 access grants, and we're going to talk about this in just a moment, how S3 access grants is integrated with IAM Identity Center to directly understand end user identities. The CloudTrail event that you're seeing here has this additional on behalf of thing. The on behalf of identifies the Magenta user directly. So if you're trying to audit who had access, this is going to, you have no further work to do. You're being told exactly who accessed it. So this is the original user identity, making direct auditing of access a lot simpler. Okay, so if you've ever seen anything in your data lake that approximates these three categories of challenge, that's a signal that S3 access grants is something that you should be looking at. All right, so now I'm going to talk about the how it works, how you integrate with it. So I'm going to talk about the kind of integration you need to do with your the integration work you need to do in your application to be able to access the data before I talk about how you make the grants. Because how you make the grants is actually the easy part. It's more or less how you think. But we're going to talk about what this data application needs to do. Well, the first observation is that it needs to do something, right? We're no longer just taking a set of, like that central IAM role that represents our application and just, yeeting requests right at S3. We're no longer doing that. Instead, we need to go to this gate. So a change is needed to our application. So what's that going to look like? Well, it's going to look a lot like, if this reminds you of our session broker picture, that's not an accident. The data application's first going to go to S3 access grants, get some credentials, then for the next couple minutes, hour, however long you wanted those credentials to live, you're going to go to S3 with those. So we're going to walk through a little bit of an example, a little bit of detail about how that request for the access followed by the access to the data works. I have an S3 access grants instance right here. I've got two grants in it, one for the blue data set and one for the yellow data set. Like I said before, two kinds of grantees in the world. So we're going to start with the IAM grantee. We have granted access to the blue folder to an IAM role called blue role. We're going to focus on that grant right now. Notice we also have another grant to a directory group, and we'll get to that in a minute. Okay, so we're going to talk about the IAM principal grantees. How do they actually get into the data to S3? So I'm going to show you this with CLI, AWS command line interface examples. Of course, any of our language SDKs are going to work similarly. So I have my identity, just to show you that my identity right now is the blue role. I did the who am I request in AWS. That's called STS get caller identity. You can see here it is telling me that I am currently the blue role. Great. How do I get into data? So S3 has a new API called Get Data Access. If you're trying to get to data in S3 where where you have access through an S3 access grant, Get Data Access is how you get in. So Get Data Access, you can see the parameters to this. I'm asking for read permission. I'm asking for a specific S3 object, data.csv under the blue folder. I'd really like to read that object, S3 access grant, so can I do it? So S3 access grants under the hood takes that request, looks up your grants, and says, you're making a request that matches something that I have. This prefix, colorful dataset / blue, I do have a grant for that. You do seem to be the grantee. The access level matches. Cool. So I'm going to, S3 Access Grant's doing this under the hood. I'm going to assume an IAM role that I was configured with. We'll talk about that IAM role in a second. I'm going to assume an IAM role. I'm going to give you some credentials back. And so here's the output response that your application will see. The first element of the response is credentials. If you've ever assumed an IAM role, you recognize these. It's exactly those. It's the access key, ID, secret. It's the keys you need to sign requests plus an expiration time that's important. And the other part of this is actually something to notice. There's also this matched grant target. Now, if you look at what you're being told, your S3 Access Grants is telling you, I know you asked for colorful data sets blue data.csv. I'm giving you credentials to get to colorful data set /blue/star. So I'm actually telling you the grant that I matched. Now, why would it do that? Most of our use cases for S3 Access Grants are big data, high volume kind of use cases where these credentials, you would not want to go to S3 Access Grants every time you want to read data2.csv or data3.csv. You actually want to make one of these requests for however many minutes, or an hour that your credentials last, and you want to reuse those credentials as much as you can until they expire. So S3 Access Grants is telling you, you know what, anything else you access that matches this pattern, just use those credentials. They're going to work for you. Now, if that's not the behavior you want in kind of advanced use cases where maybe you only wanted access to data.csv, there's an option to do that. I'm not really going to talk about that here. So now I have credentials. I didn't want credentials. I wanted data.csv. So here's how I do it. I'm using those credentials. If you were using a language SDK, this part would look like instantiating an S3 client with a new credentials object. It looks like that in pretty much all of our languages. I'm making an S3 client using the credentials they just gave me. And I'm requesting the object, and I get my data. I go to data2.csv. They work as well because it matches the pattern. And I make as many S3 requests as I possibly can until the credentials expire. So that's how it works. First ask for access, then use the access. All right, so that was how a grantee who is an IAM principal gets access. What about authenticated data users? Well, this is something very new and exciting. Until this week, S3 did not know anything about an authenticated data user. It only knew about IAM entities. So how does this work? If my application is authenticating users through like a single sign-on, they get redirected to the identity provider, username, password, MFA, get sent back to, how do I possibly get that into AWS? So this is a capability in IAM Identity Center, which is a service I'm going to talk about in just a second, called Trusted Identity Propagation. You can see why it's called that. I'm propagating an identity into AWS all the way down to S3 so that it gets, and finally logged to CloudTrail. This identity, the yellow user, really makes it all the way to the end. Okay, so as you might imagine, there are a few more players in this game now that I'm using end user identities. So first of all, there's my directory, my identity provider. Could be Azure Active Directory, which is now known as Microsoft Entra ID, could be Okta, could be any number of the identity providers numerous identity providers that are supported by our IAM Identity Center service. There's the IAM Identity Center service. This service used to be known as AWS Single Sign-On. You might be using this service today to allow your cloud operators, who are also people, to federate into to operate into the AWS console to work on the different accounts that they have access to. It's in fact a best practice way. If you're looking for a good way to get your cloud operators into AWS, this is what we recommend. Use IAM Identity Center. IAM Identity Center supports your identity provider supports a one-way synchronization using a protocol called SCIM. So basically what that means is that Identity Center is the hub of all user-centric activity in AWS. And then, through the means I'm going to tell you about, this user identity is on every subsequent interaction that I make. This is the identity propagation part. Okay, so I'm going to say just a few words about IAM Identity Center. This is not actually specific to S3, but relevant because we support this in S3 access grants. So in order to onboard to IAM Identity Center, if you work for a company that has an identity provider, if your identities are in Microsoft Entra ID, Okta, et cetera, what you'll want to do is you'll want to, either you or your identity administrator, whoever has the permissions to do this, set up a synchronization of your identities into AWS. A lot of identity providers call this automated provisioning. That's another word for it. What that means is that AWS will now have a view of the users and their group memberships from your directory. So something changes in a directory, a user joins a group, a user leaves a group, a user isn't in the organization anymore. That gets propagated, pretty quickly over into Identity Center. And now anything in AWS that understands identity knows about this user. Identity Center, if you don't have a directory, also supports, it has its own sort of self-contained identity pool where you can you can create users and groups and API to do that. But I'm really going to focus on because most of our use cases involve users who came from a directory, I'm going to kind of focus on that, although it applies just as well if the identities are in Identity Center. So Identity Center actually, this is its third main category of use case. So its flagship use case, back when it launched as AWS single sign-on, I think it was maybe 2017 or thereabouts, was federating users into the AWS console, right? Your cloud operators getting into your accounts. So that's still there, still great, still our best practice recommendation. A little bit later, they also supported front door authentication into, we have some AWS services that are actually better called applications, things like SageMaker Studio that users actually want to authenticate with. They serve end users rather than cloud operators. So it served as, still serves as front door authentication to those services. This is a third new and very exciting new use case here. Trusted identity propagation is the ability for identities that are known to Identity Center to be used in AWS services, such as S3, and a couple of other analytics services around AWS that launched identity support this week, including Redshift, Lake Formation, QuickSight. We have a number of use cases that now make use of this capability to support identities directly. Okay, so back to our application. We have these users. These users do not know how to spell IAM, right? They don't need to federate into any kind of AWS account, IAM role. They don't need to know what that is. They just sign in. Right? They get directed to Microsoft Entra ID, username, password, MFA. We're back in the pie chart maker, right? Let's make some pie. So the first thing that happens in our application is the first thing that happens in any corporate application that you use, you get redirected for the sign-in, or maybe if you signed in a little while ago, it already has that. That's kind of between your application and the identity provider. AWS not really involved in this step. So now we have the identity. Well, we have the identity according to your identity provider. We don't yet have an identity according to AWS. So how do we get that? Well, the next thing your application is going to do is it's going to make a request to Identity Center, say, hey, I have an OIDC token from an identity provider. I'd like to use this identity in AWS. I'd like another OIDC token, but this one's going to be signed by AWS and usable in AWS. Now, you might wonder if you know something about authentication. Well, why did that work? How did that work? How was AWS able to recognize an identity token that came from out there? And that's actually a configuration detail. You actually set that up ahead of time. It's called a trusted token issuer. Basically, you set up a relationship. You say, hey, you're going to get identity tokens for this audience signed with these keys, and then and this is how you map them to identities in Identity Center. It's pretty straightforward. And Identity Center is able to do that mapping. You're like, okay, it's this user. We're going to give you an onward token. By the way, everything I'm describing here, if you are looking at this application saying, this actually sounds like something I want to learn how to build, we have a two-part blog post that actually goes into a great level of depth in how to do this, including like the code you would write at each step and how the configuration looks. It's called Developing a User-Facing Application using Identity Center and S3 Access Grants. It's written by me, Becky Weiss. You can look this up if you want, just like the full detail. I go through a specific example of an enterprise application in the Microsoft Entra ID, in a Microsoft Entra ID directory, and take you into AWS and into S3 access grants and finally getting some data. So if you're wondering what the details are here, we got them for you. Okay, but now I have an identity that AWS is going to know what to do with. The next thing I need to do is I need to, well, we saw this part before. I needed to call S3 access grants to say, okay, I've got the yellow user. They're going to want a pie chart with yellow data. So why don't you give me access to that? But hang on a second, there's a problem here, which is that S3 access grants, that get data access, regular old AWS API, we need IAM credentials to call it. So there's a step here where your application actually assumes a role so it can get some credentials using that token as additional context. So now I have an IAM session that's not just an IAM session, it's an IAM session and a user identity. And so that's what happens from here on out. So S3 access grants gets my request, unpacks the identity. See, this is the new part, right? An AWS service understanding the identity. Under the hood, it's talking to Identity Center, figuring out the group memberships. Oh, this guy's in the yellow group. I have a grant for that. So it decides to send me back credentials. The credentials it sends me back are also decorated with their identity. That's why the CloudTrail part works. All right. So if that was a little bit much to digest, you should go look at that blog post. A little bit more about S3 access grants, accounts, and regions. An S3 access grants instance, like that table of grants you saw, is specific to an account and a region. So if I have a S3 bucket in a particular account in a particular region, and I want to do S3 access grants with it, the grants are going to be assigned in that same account and in that same region. In other words, if I have S3 buckets in a couple of different accounts, I'll have S3 access grants instances in each of their respective accounts. And I'm going to, and we also have an API to help you discover which account you're talking to, because bucket names don't actually have accounts in them. So we have a way to kind of help you find the right S3 access grants. Other thing about S3 access grants is you can do cross-account grants. Of course, the physics of IAM still apply. So it's going to be an IAM entity in a different account calling get data access. So there's a IAM resource policy on the access grants instance. Because again, these are the physics of IAM. The rules of IAM is if a cross-account request is being made, there's a resource-based policy in the middle, so that's happening here too. So that was actually the harder part. The easier part is like, how do we make these grants? It's more or less what you think. There's of course a console to do this. I'm going to show you the command line interface just so I can show you some of the details about what goes into a grant. First thing to mention, if you're going to be granting two identities, there's a one-time step to connect your S3 access. It's a one-click in the console. Connect the access grants instance to Identity Center. That just tells S3 you're going to be talking to Identity Center. So I can create a grant. And how do I create a grant? Well, I have to say who I'm granting to, so that's a grantee. Here I'm doing a grant to a group from my directory. I say, what am I giving them access to? So I'm saying read access. What am I granting? So you'll notice here it says S3 sub prefix. You might wonder, sub of what? Hold that thought. But this is the prefix, right? Example bucket. And then I say the default location. Now you might be wondering what a location is and what does a non-default location look like. Location is an advanced concept in S3 access grants. Usually you're going to use default. So what's a location? A location, actually, if you think in terms of IAM, a location is a thing that you can hang an IAM role off in S3 access grants. So the default one is for S3://. That means anything in this account, anything in this account, the session that you create, the session you hand back to the application should be from this role. But we've talked to customers who, for one reason or another, need other IAM roles in place. So a location is what lets you do that. So I could, so for the default location, it's associated with an IAM role. This is the IAM role that will be assumed for these credentials. But if I needed a second role here for whatever reason, I could make another location. I could make a location at other bucket, which is also in my count. And so the sub prefix is relative to the location. If you're only using the default location, you don't really need to think about this, but there is a way to do this with multiple roles. Finally, I wanted to say a word about how this works with other services in AWS that get involved with your data. First of all, I didn't really mention this before, but you might be wondering, what if I've used server-side encryption with KMS to encrypt my data in S3? How does that work? Well, S3 access grants doesn't get in the way. The session that it hands back has permission to do KMS things. And then, whatever IAM permissions were there on your KMS key, they're all in play there. So nothing's really changed about the physics of IAM with KMS. It's just that S3 access grants doesn't get in the way of that. You might also be wondering, well, what does this have to do with lake formation, right? Like, if you're kind of paying attention to the details of Rob's description of lake formation and my description of access grants, these kind of sound like they are both sitting in the same place in your flow. They're both a gate before you actually access the data. So when would you use which of those? This actually comes down to how does your application interface with data in S3? If your application talks SQL, if your application is thinking about tables and schema and the way it talks to its data is with select queries, you should be looking at lake formation for that, because lake formation, which is closely associated with the AWS Glue data catalog, knows all of the schema of your data, knows how it's laid out, is integrated with AWS compute engines such as Athena, and it can do a lot more with your SQL query than S3, who doesn't know what a column is, can do. In contrast, if your application speaks get object, put object, list objects, if your application speaks the S3 object API, then S3 access grants is going to be the more natural fit for how it's supposed to get access to it. You can have both in play on the same bucket. If you have some that speak SQL and some that speak S3 access grants, they don't conflict with each other. Both of these services, again, are not alternatives to IAM. They're on top of IAM. So all of this can coexist peacefully. Finally, we have an integration in AWS with S3 access grants. This is Spark on EMR. So EMR is Elastic MapReduce, basically runs and manages a giant cluster of various kinds of analytical software for you, most popularly Spark. And when you use Spark on EMR, it uses the EMRFS file system that EMR has built to be able to do a lot of advanced things. EMRFS is integrated with S3 access grants. It's also integrated with lake formation. And actually, your EMR on Spark cluster is smart about how you're interfacing with the data and which one of these to go through. It's even identity aware. EMR Studio is kind of user-facing application front door and on top of EMR. And if you go through that, you get your identity integration as well. Support for S3 File I/O and S3A for S3 access grants, because these are both popular libraries used to access data. Those are in the works. We're working on those. But yeah, even today, you can, if you use EMR to access your data in S3, you can put S3 access grants behind it, some configuration in EMR to tell it to use S3 access grants, and now it's going to do different permissions for different users of Spark. It's pretty cool. So that is S3 access grants. So what did we do today? We actually talked about the options that you have. You actually have quite a few options. And some of the options from earlier in Rob's talk are actually very appropriate for you if you fit within sort of the scale and the scale constraints of those solutions. They're very simple, direct, and effective. They've been around forever. And as you sort of moved up the scale and complexity and different shapes of different scale dimensions, we talked about access points. We talked about if you need kind of like the ultimate dynamism, like do anything you want, build that STS session broker. And we're really excited to offer S3 access grants. We think this is, this tracks how most of our customers have described to us how they think about these large-scale data lakes once they get past the scale and expressivity constraints of some of the pre-existing solutions. So we're really excited. Rob and I would love to talk to you after this session. So please come up, ask us anything. We're really excited about this. And thank you so much for coming to this session. I hope you have a great rest of your reInvent.